Good morning again. It's the 23rd of August now. It's just after 7:30 in the morning in New York, and we're in the Concorde lounge at British Airways terminal here at Kennedy Airport. Our passengers are just beginning to check in for our flight, and their aircraft is parked just outside the lounge, and we're intending to be departing on schedule in just over an hour's time. I'm going to go downstairs now to start the flight briefing process in the Flight Crew Centre. So we come downstairs now to our operations office, to the flight briefing unit in the terminal at Kennedy Airport here. And this is where we get our paperwork, so we can make our decisions about the fuel that we're going to take with us on the flight. The essence of flight briefing for any flight is really quite straightforward. Basically, you check that the weather's suitable for takeoff and landing, and that you know how long you're going to be in the air, therefore you take enough fuel, and then you can go. But of course, with complicated long-range flights, it's a bit more complicated than that. We start off by actually telephoning the automatic Met broadcast to check that the weather is okay here at Kennedy Airport itself, and we've made a note of that. And at the moment there's a light southwesterly wind. It's quite misty out there, as we know, because we've just driven into the airport. Clear skies above the mist. It's humid, 22 degrees temperature and 22 degrees dew point, and they're taking off on runway 31 left, which is to the northwest. Also, they've told us that they're not using the full length of the runway. There's some work going on the southeast end of the runway, and they've advised all aircraft to expect a departure from a taxiway which is known as Taxiway Yankee. All taxiways have letters that designate where they are. So we've also got a printout of the airport just to check where Yankee is, and it's very nearly the full length of the runway, and Les has already checked that we've got figures to work from Taxiway Yankee in our book, so he's able to start doing the calculations for our takeoff limitations. So we know that we've got an operation out of this airfield, and that's the first stage. Then we start thinking about the route as a whole. The first thing we do is actually have a look at the overview of the Met. We start by looking at the significant weather chart, and already there are charts in here also that set out the upper winds, and Les has already had a look at those to check that the fuel flight plan calculations have been done on sensible wind figures. We look at the significant weather chart, and we can see on this that there's the US and Canada on one side here, the Atlantic, and the UK and Europe on the other side. And at this time of the year, it's really quite quiet across the Atlantic, very little jet stream activity, very little high cloud or turbulence around. And in fact, normally we're flying above those sort of conditions, but we have to be aware of them in case something makes us descend and we have to get down into that normal subsonic weather. But a good overview suggests it's good flying conditions on the route today. As I say, Les has already looked at the upper winds, and the other thing that's on this document is a radiation forecast. Concorde is unique in that we measure cosmic radiation, and we get a forecast from the office here in the States which tells us what the radiation activity is likely to be like today. It's saying it's green at the moment, which is perfectly normal, safe radiation, with a 1% possibility of it increasing just a little bit, but nothing that's hazardous at all. But we get that for every flight as well. So having had an overview of the weather, we then start to look at the weather in detail. And we start with, obviously, where we are. Well, we know the current conditions, but we also want to know the forecast for today, for here, in case we have to turn back at all. So we've got the forecast ahead of us, and it says that it's a partly cloudy, misty day, and a chance much later in the day of some thunder showers and some rain around. We'll be gone by then, and that won't affect us. So as far as a return is concerned, it's operable, although it's a bit of a hazy and not a very pleasant day. We also look at the facilities available on the airfield, and we can see from these that most things are working. There are 1 or 2 runways closed, but they don't affect us, and the airfield, as far as we're concerned, is okay for our use. The next piece of information on this piece of paper is the weather in London, logically, because that's our destination. And we look at that and see that the forecast for London is a partly cloudy day, a light southerly wind, with some rain around, in fact, and about the time we're going to arrive, there's a possibility that it's going to be a little bit more gusty from the southwest, and with some rain showers about in the area. So that's gives us a picture for when we arrive. We also actually have a report of what the weather's like at the moment, and that bears some resemblance to the forecast, so we know that the forecast has a good chance of being pretty accurate. At the moment, the temperature in London is 15 degrees Celsius, and there's some cloud around, but it's not raining at the moment. We then look at London as far as the airfield is concerned to make sure all that we need is operating and working, and any other information we need to take from this, and we can see that there's quite a bit on here, but nothing that directly affects our operation. Turning the pages over then, we can go down and look at our alternate, which is Gatwick, and again the weather's very similar to London, as you'd expect. It's very close, and that's quite all right for use as an alternate for us, and again the facilities available on the airfield, there's nothing there that significantly affects our operation. Another airfield we may consider using as an alternate if Gatwick gets rather busy is Stansted, and again there's more information in the same way for that. And again it's very similar to London. The whole of south of England looks like it's in a very similar weather state. There's no significant problems on the airfield that would stop us using the airfield either. So we know basically now our point of departure and our main destination and alternates. We then follow this piece of paper down. It takes us through information about the United States air traffic control system generally. Again, nothing that's directly going to affect us, and also covers other areas such as Iceland, the Atlantic, and then across to the United Kingdom. So this is route information to see whether anything's not working that we may wish to use. And while there's a lot of writing here, none of it directly affects us. We then come down to any significant weather warnings, and again at this time of the year it's usually reasonably quiet unless there are hurricanes around, and there's no significant weather warnings for anywhere on our route. We then get down to the final bit of information which tells us how many passengers we expect to get on the airplane today, 85. There's no special load, so we know there are no special conditions as far as loading anything in the hold is concerned. And finally, that as far as the engineering is concerned, there's no ops defects that will affect the operation of the aircraft. So that's done the basic route from beginning to end with some information about the aircraft. So having covered the basic route from point of departure to destination and our main alternates, we now then follow the paperwork down and look at some of the airfields that we may have to consider en route if we have to make a diversion anywhere. And basically it starts by following the route from the eastern seaboard across to Europe, and including Canada, of course. So looking down here, the first one that I cast my eye on is Newark. That's very close to New York, and of course if we have to come back and New York isn't operable, we just want to make sure Newark gives us an alternative choice. And it's very similar weather to New York and throughout the rest of the day. We can then follow this down. It takes us down eastern seaboard places that we're not particularly directly interested in, and takes us across, in fact, the Atlantic to Prestwick, for instance. And if for some reason we had to divert up there, I can see here that, again, the weather there is showery, basically quite reasonable, good visibility, some cloud around, nothing to worry about. Continuing to turn it over, it looks at Shannon in Southern Ireland. That is a major diversion airfield for us, crossing the Atlantic, so we're quite keen to know what the weather's like there. And again, the forecast for there is some good visibility, some broken cloud around, and during the period when we're anticipating to arrive, there may be some rain showers. The weather report they're giving ties in with the forecast. There is some rain around there at the moment. As far as ourselves and the weekend is concerned, it means that probably will be some rain at home over the weekend if it's coming in an easterly direction. Then looking down further, we're just checking for places like Santa Maria, which is in the middle of the Atlantic and to the south of our track. And again, it's a place we may have to use as a diversion en route. That's actually quite a nice day there. A light northwesterly wind, good visibility, clear skies, a little bit of light cloud around. So that's very good. Just coming back a little bit to Halifax in Nova Scotia. Another major diversion airfield for us, a bit more in the forecast here. But it actually says that the wind is southwesterly, a good visibility below some cloud, some broken cloud, and basically overcast skies a little later on. Again, a fine day as far as we're concerned. Gander, again, another major field that we may have to use sometime. A little bit less in the forecast here, but throughout our period, again, southwesterly winds, good visibility, a little bit of high cloud around, really quite a pleasant day. So we've had a look at the route weather there. We keep checking to see if there's anything else that comes to our attention, but with the weather as good as it is, we needn't go through all of the places in detail. And finally, just getting back to the UK, a quick check at Birmingham, because that's actually not too far from London and a good alternate for us to use. And the forecast from there suggests some rain showers, as we'd expect, across the southern part of England, with some southwesterly winds. So not very pleasant, but all quite operable. Carry on turning the page over. We just check that the airfield states are okay, that we may want to use. So again, we looked at Prestwick for the weather. The airfield's operable for us there. Shannon's okay. And nothing really that should prevent us. Santa Maria's okay. And Birmingham is fine. And we know from looking down here that some of the other airfields like Gander and Halifax have no significant defects to affect our operation. So we've had a good look now at the weather and at the state of the airfields as well. So basically, having decided that we can go, that we've got a route operation that's operable, the next thing just to have a check of is our tactical situation. I briefly showed you the tactical chart on the aeroplane yesterday, and what we want to make sure is that we have got somewhere to go to at all times should we have to shut down one engine. And the calculations have been done from the computer, put onto a graphic presentation of the North Atlantic tracks. We can see quite clearly from here that we've got a good overlap, so we've always got a choice of one or two, sometimes four places to go to if we have to shut down one engine and go on to three engines. We can also see that the subsonic tracks used by the normal subsonic aircraft are away from our track, so if we did have to descend, we know that we wouldn't be descending into their track system. And we'll monitor our progress throughout the flight on that chart. Les has already started doing some of the takeoff calculations, as I've said, and he's also checked that the route on the navigation log is correct and we've got the right paperwork. And it really now brings us to the fuel flight plan. Les has already checked that the winds are in there and the figures are sensible. And we've come now down to making a decision about how much fuel to take. In doing his figures, he's checked to make sure that, first of all, we're going to be taking off at a weight which is below our maximum limiting weight, so we're OK as far as weight restrictions are concerned for performance. And also at Kennedy Airport, we check our noise weight as well. We have noise charts that actually give us an idea of how much noise we may generate in the area, and we try to make sure, obviously, that we're very good neighbours, and therefore we're conscious of our noise limitations as well. We've got plenty of weight in hand as far as performance is concerned. We're actually quite close to the noise limiting weight, but on a day like this, it's not too surprising. Our route should keep us clear of the noise monitoring posts. Our fuel flight plan suggests that we need a fuel figure of 86,130 kilos. Now that's the fuel necessary for the flight, some extra contingency reserve fuel, a fuel for a diversion, some more reserve fuel as well, and enough fuel to make sure that we can fly the normal departures and arrivals. That figure gives us all our normal reserves. Now the decision is, do we need to add any more to that before we put the final fuel figure on? And looking at the weather, and bearing in mind it's Friday night as we get in there may be the possibility of maybe 5 minutes in the hole. I'll stick a little bit of extra fuel on, not very much, but just to give us a little bit of a cushion. So I think we'll take 90 tonnes in tanks. Okay, Les?
Yeah.
So if we take 90 in tanks, we'll take a standard taxi fuel of 1,400 kilos, because we're not anticipating any delays here out of Kennedy. And that'll give us a extra fuel figure. I can't quite see the numbers, but off the top of my head, something like 2.5 tonnes of fuel, which will give us a few minutes extra cushion for holding at the other end. We've got holding fuel in there anyway. This just gives us a little bit more. And then what we'll do is pass that figure on to flight planning here. We'll pass it on to engineering. They'll start the refuelling of the aircraft. The people who prepare the load sheet will start putting those figures in their computer to produce our balance and load figures. And Roger, of course, will go out to the aircraft in a while and start to liaise with the engineers and get the right figure on board. Is everybody happy with that as a figure?
Fine, you
okay.
And
that, in fact, leaves us just under 2.5 tonnes of fuel extra, which will give us a little cushion, as I say, at the other end. So we'll gather the paperwork up. Les will look after all the paperwork, and we'll go out to the aeroplane in a short while and start to prepare it for the flight. During the briefing, I mentioned that we were planning to take off on runway 31 left here at Kennedy Airport. That's the left hand of the northwesterly facing runways. And I thought that before we went up to the aircraft, perhaps it would be a good time to show you on this chart exactly what that routing is going to be for departure. This chart shows the Kennedy Airport area, and of course this light blue area here is the water of Jamaica Bay, with this spit of land which are the Rockaway beaches, and then down here the Atlantic Ocean. This is the borough of Queens, and away up on the left hand side the East River and Manhattan. These are the runways at Kennedy Airport, and as you can see there are two pairs of parallel runways, two pointing northwest-southeast and two more northeast-southwest. We're going to take off on the left hand of the northwesterly facing runways, runway 31 left, and we'll start our departure from here. And obviously we'll be heading out in that direction. So we want to start a procedure that actually keeps us away from this populated areas and actually make sure that we remain a good neighbour to the local community and minimise any noise readings we get. So when we started operating out of here, we developed this following procedure. Having got airborne about here, once the gear's selected up, we start a left-hand continuous climbing turn round the edge of Jamaica Bay, keeping us just to the water side of the populated areas, and bringing us over this VHF nav beacon here at Canarsie, and down a radial over this disused Naval Air Station at Floyd Bennett Field, and across a large car park on the Rockaway beaches. And that takes us out over the Atlantic Ocean, and then we start our turn and climb away across the ocean and accelerate. To achieve this procedure, to get the right heights and to get the right footprint of our noise on the local area, we actually carry out quite a complicated manoeuvre of throttling back the engines, getting the precise bank angle, then putting some power back on again, reducing the bank angle, putting more power on again, and then off again as we come across these various landmarks. The net result is that having flown this procedure, we avoid the main noise monitoring posts, we avoid the main areas of population and the built-up areas, and actually during the years we've been operating here have had really comparatively few noise violations filed against us, certainly no more than regular subsonic aeroplanes get. So we do our very best with this departure to be as good and friendly to the local community as we possibly can be. Well, welcome back onto the flight deck. We're here at gate 2 at our terminal at Kennedy Airport, just getting the aircraft ready for departure. We've done our scan checks, the aircraft's been refueled. The passengers will be boarding very shortly, and we're just about to start our checks. While we've been sat here, we've been getting the latest information from the airport, and they've just advised us that they've made unavailable a little bit more of the runway, so we've had to redo our performance figures and check that we can actually get airborne on that available runway length, which is we can just do. So we're going to go ahead with that as our departure. So it's the same runway that I talked about while we were in the briefing room. So we're going to get on with our checklist now, and of course we're going for an on-time departure.
Master CB.
Set and checked.
Set and checked, no flags in the middle.
Cockpit preparation, security, mine's complete.
Mine's complete.
Complete.
Oxygen check 100%.
Check 100%.
On
CB
check
windows.
100%.
I'll leave mine for a while.
Flight control inverters are on. Anti-stall systems off. Radar which is
Radio.
red. Instrument transfers
Set.
Altimeters.
3013.
Yep.
13 feet, 613, 20 feet, and normal selected.
Okay, checks and set. Nav radios.
Canarsie on mine, Kennedy on yours, 176 until we get the clearance. 235, 253, 5,000 feet. Then we've got the local beacon on
Okay, set.
both ADFs.
Brakes, park, pressure check here.
Available's good.
Nav lights.
They're off.
Throttle masters.
They are alternate.
Ground hard checkout.
Yellow, yellow and off.
Fuel heaters.
Auto.
Engine reset valve.
Shut.
Secondary air doors.
Selected auto.
Check batteries.
They are on.
INSs.
Present position from the book. Gate 2, north 40389, west 73472.
Check.
Okay. Starting at waypoint 6, down for first 3. Ship, north 40197, west 73149.
Check.
7 is Leos, north 39585, west 72384.
Check going.
Number 8 is Lynn, north 39246, west 71428. All the rest have been checked and the DME's checked.
And ready for nav.
Ready for now.
Nav on 1, 2, 3.
Loading check.
Ready nav lights out.
Auto and 0.
Loading
Loading
check, nav mode and
mix
mix.
here. ASI bug pitch index.
Right, I've set these twice on the standby as well, so it's 169, 190, 211, 250 and 251 close together, and 13.5 degrees cross check.
Cross check.
Checked and set.
Fuel flow, piece of bug.
Take it to agree these, Roger.
Yes, we have.
205201,
Agreed.
392386.
We are on one below you.
I'll accept your readings, thank you.
Briefing comes next. Oh, clock and TLA bugs next.
Clock and TLA, 61 seconds. 101, set around both sides for 12 degrees.
12 degrees set.
19.5%.
And then the briefing.
Briefing, it's 3-1 left from Kilo. We've negotiated that
Okay.
with the authority, and it's a stop situation. Left-hand seat, normal 3-1 left departure procedures with the normal calls. Turn, 321 noise, 235, bank angle back to 7 degrees, and then the height 2,500 feet. I can do what I wish with the bank. I'm looking for the radial 253. Depending on where the give is in terms of radar vectors, and if I can see where I'm going, I might call noise now visually, Roger, okay?
Okay.
They'll take the power up at 5 nautical miles.
Okay.
Expected to head out at some stage for a direct to Lindor ship.
Yep.
Safety height in the area is 2.8 inland, of course, and the highest safety height on the way out is 3,000 feet, so we'll use that as our safety height. We're climbing to 5,000 feet.
Okay.
As I said, it's a stop situation, normal emergency briefing as given yesterday.
Fine.
And if we find ourselves airborne with an engine failure, we'll adjust it so that above 100 feet, the bank angle is 15 degrees.
Correct.
Okay.
Okay.
Well, departure time's approaching, and we've, in fact, all completed here. The paperwork's all complete, and we've got the documentation. Just been informed now by our duty manager that the number of bags we've got on the aircraft doesn't tie in with the computer tally for the bags we should have on the aircraft. In fact, he's suggesting we've got 2 more bags than we should have. It's quite likely, and very often, if these situations occur, that they are in fact computer errors. But of course, we can take no chances. So what I've asked is for the bags to be taken off and all to be identified, and we won't go until we're sure that we've got the right number of bags and they belong to the right people. So this is going to cause a delay in our departure. It's one of those inevitable things nowadays with the security-minded industry that we're in, and we'll just have to wait and go when we know the situation has been resolved. In the meantime, I'll obviously be talking to the passengers and letting them know what's going on.
One of the primary functions for the flight engineer on Concorde is CG control, and this starts right from the beginning of the flight. We've now been presented with our load sheet, and we take figures from this load sheet to set up our centre of gravity computers so that they will give us an accurate centre of gravity throughout the flight. Firstly, I will set up the zero fuel weight, which is 87,500. In this case, the zero fuel CG, which is a centre of gravity that takes into account the whole of the aircraft except the fuel. I need to set that up to 5288. Having set those two up, this unit here then has 3 computers that are operated from it, and they take the information that I have put in, plus the fuel gauges, and indicate a centre of gravity here for us. For takeoff, that needs to be 53.5, and you will see us moving that during our taxi. I also need to set up this unit, which gives us an instantaneous readout of how much fuel we've got left, and also the weight. Firstly, I need to set up the zero fuel weight again. 87,537 is the actual zero fuel weight. I now set into the one at the top here, the actual fuel we have on board, which is 90,000 kilos. As it goes in, it automatically adds on to the lower figure to give us an instantaneous weight, 177,530. Having set those figures up, I need then to set one of our transfer units up so that we can undertake the transfer during the taxi that will achieve 53.5 as a centre of gravity for the takeoff. In this case, I need to set 6,180, which I set into this selector, and then it is all ready for us to do the transfer during taxi. All these figures come from our load sheet, and they are confirmed by each of the crew members during the checklist operation.
Load sheet.
Checked.
Zero fuel weight, zero fuel CG.
8755288.
Checked. Fuel remain aircraft weight.
90,000. 177,530.
That checks. Correct. Load limit.
They are set for a transfer.
Takeoff data, we know all about that. Start clearance we've got. Door line.
Just the miscellaneous hatches.
Master warning. Thank you.
Can take the air conditioner away, Graham.
Checks all what we know about.
I'll put 220 in there for bridge, Les.
Okay. I'll put bridge on the...
Yeah, I've seen that.
Flight deck ground.
Anti-collision line.
It is on.
Throttles.
Idle.
Engine P-pump.
They are on.
Over you, to you, roger, start.
Well, the baggage situation's been resolved, as we suspected. On the rare occasions when this does happen, it was a computer error, but we need to be very certain about that. So all the bags were taken off individually, physically checked against the baggage tags and their owners, and they're back on board now. We're just having the ground air start plugged into the aircraft. We've got our air traffic control clearance, so we should be on our way very shortly. It's taken, that whole process took about half an hour or so. We should be pushing back, starting our engines in just a few minutes' time. Same clearance as we anticipated, off 31 left with a left-hand turn, and actually climbing away across the southern shoreline on the southwesterly heading rather than southerly heading. But air traffic control will no doubt give us other headings anyway on the way out, so it becomes a bit academic at this stage, but that's what we're planning for at the moment. Just a few facts and figures. We actually weigh, we will weigh on takeoff 175.5 tons, and the takeoff fuel will be just about 88 tons with that, so 88 tons of fuel weighing 175.5 tons. And our flight time is expected to be 3 hours and 17 minutes, a slightly slower crossing than we perhaps normally expect. That's because the temperatures were quite high, and the upper temperature is quite high at the eastern end of the Atlantic, and there's a few headwinds as well as we come down there. But headwinds and temperatures affect us a little bit, but not too much, not as much as ordinary subsonic airplanes.
We've got the air pressure.
And we'll be on our way very soon. We're just about to start our engines.
Hello, ground.
Roger, you're clear for startup.
Thank you very much.
All yours, Roger.
Thanks. We're ready now to start the number 3 engine. First item we do is select the start valve open and check that the start valve actually moves. From here we come to the front of our instrumentation to check that the engine is rotating, and when it gets to 12% on the N2 we put the fuel in. The fuel has gone in, we check we have a red light on our engine shutdown handle, T1 light has gone out, start pump and ignition is on, and that we have light up. Now in this case I have stopped the engine at approximately 30%. If the engine has been shut down in the last 4 hours, we are in a position where the central core of the engine gets very hot and the heat transfers to the upper half of it and it bows the main shaft. We have to do what we call debowing, and we do this by running it at a sub-idle of 30% until the temperatures are evened out. When we've had the necessary time, which in fact is a minute at this stage, I then select the debow off and the engine will run up to its normal idle position. Finish with the air on the right-hand side, ground. We're looking for it to go through 67% for our rotating stall. There it is, gone through to 70, and then it comes back a bit. And then we put the systems online for that one engine.
Ready for hydraulics.
Hydraulics coming now. Number 2, ground. In this case, we don't need to stop in the debow position, so I allow the engine to accelerate straight through the 30% N2 to its normal idle position. Finish with the air on the left-hand side, ground. You can take the ground electrics away.
Number 3, number 2 engine.
They are running.
Hydraulic.
They are checked. One of our items
To the
we
right, down D.
check at this stage is our emergency electrical generator, which is hydraulically powered. I've now selected it, and we come down to these indicators here to make sure that it is operating correctly and delivering the electrical power. Having done that, we put it in a standby mode.
Hello, ground. Just make sure the ground equipment's all clear. We are clear to push when you're ready.
All right, we're clear for pushback. Parking brakes to release, please.
Brakes released. This time it's 1332.
Item 32. And you're clear to start 4 and 1.
Thank you very much.
So number 4, number 1 engine.
They're running.
Nose wheel steering check. Flight controls, air system trim.
All checked.
Tap and fill all engaged. Engine end tight, engine schedule.
It is off, and we are flyover.
Brake fan.
On,
Idle switches.
low,
Door warning.
tested and off.
Engine P-pump.
All on.
Hydraulic.
Checked.
Electric.
Checked.
Full
Ground
ground
bypass.
equipment clear. I've had the thumb. He's got the pin. Clear starboard.
Thank you. Nose to 5, please. 747 in the way at the moment. So we've completed the pushback. All 4 engines are running. We don't need air traffic control taxi clearance until we actually leave the British Airways terminal area, which is just ahead of me on the left-hand side. There's one of our 747s departing from there just ahead of us, so there'll be little delay as we taxi out behind him. And then we'll be taxiing round to the other side of the airfield for our departure. As well as following the actual handling of the departure, we're also going to follow today a little bit more closely the procedures and following the checklist. And Roger will be explaining to you what he's doing and what we're all doing as the checklists progress through the flight. Jumbo's moving now, so we'll move on our way. Clear on your side?
And clear on the right.
Clear on my side.
The taxi checklist is split into a number of items that involve all of us, and then in some cases are activated by the engineer only. If that is an engineer item, we actually do it silently, but all others I have to call out and get the requisite responses from the other 2 crew members. The first item is visor and nose.
Heads down, 5 degrees.
Brakes,
Have been checked and are normal.
flight instruments,
Okay, 036.
036. No flags on my side, that cross-check.
Check the standby.
Checks in the
Check no
middle.
flag.
flight controls, EFC,
Blue and the lights out.
trims,
I've checked and set.
Set for takeoff.
set for takeoff, All those items are confirming checks and tests and selections that have already been made, and we now revert to the flight engineers panel back here to actually set up the centre of gravity transfer. At the moment we're indicating 52.5%, and we need 53.5% for our takeoff. To do this, I transfer fuel from the front of the aircraft all the way down to the back of the aircraft. I have already set up a selector here which will limit the amount of fuel that is moved, and I can now activate that system by making this selection. The pumps in the tank at the very front of the aircraft come on, and I come down to look at the gauge, and we see that it is starting to move, so we know the fuel is moving in the correct direction. From now I move up onto our overhead panel and set up the switches for our engine ratings. Takeoff rating for the engines, switching the auto ignition on.
No problem, so that's 600 kilos.
We then change our electronic throttles to the other system to make sure that both systems are working correctly, checking this on our engine gauges at the front of the aircraft, returning to the original selection for takeoff. We select our drain mast heaters. They're the heaters in the masts on the outside of the aircraft where water from the sinks goes overboard during flight, and we don't want to have it freezing as we go.
So it's coming way down there.
We make sure our engine rating is selected to climb, so that when we come away from takeoff rating, this particular switch is already in the position that we need it.
So we're going to go along to
static
there.
heaters are switched on.
Yeah.
ADS engine probe heaters are switched on. Then come back to look at our intakes. They don't start to operate until 1.3 Mach, but we make sure at this stage that they are all operating, that there is no warnings to indicate that there are any difficulties. We have a system using our primary nozzle on the back of our engines that allows us to set up the engines for minimum noise, maximum power, and various other settings. Well, in this case we go to flyover. That gives us the maximum power for takeoff, but when we undertake our noise abatement, it minimises the community noise that we create at that stage. We also have to make sure that our number 4 engine limiter is selected to 88%. This holds the number 4 engine for about the first 50 knots of our takeoff run at a slightly lower RPM than the others. We then go ahead with the rest of the panel checks, including the check of the air conditioning system, and you will probably have heard us having to switch the number 3 system off because of a duct warning that we had just after startup. We come down to look at our refueling panel at this stage. We check our fuel protection system. It is selected. We also look at our fuel consumed indicators, which are along the bottom here.
Wide move.
Now these indicators in fact show us the amount of fuel that is being consumed by each of our engines. And you have to add another naught on the end of here, and it is indicating in kilos. As these increase, the figure that I set into the total fuel remaining decreases, so that it always ensures that this indication is the instantaneous fuel that we have on board at any given time. You can see it going down now, and also you can see the weight reducing as we burn the fuel. We make sure all our engine feed pumps are on. These are the 3 pumps in each of the main collector tanks that supply fuel direct to our engines. But the crossfeed valves are selected closed and indicating closed. We then have a look at our anti-skid system, and to do that we have to be moving forward at about 10 knots. So at that stage I have to hold the checklist until such time as we can move further up the taxiway. While we're still waiting here, in fact our fuel transfer is now completed, so that I can actually set the panel up for takeoff. First of all, we have to look to make sure that we have the correct settings. 53.5 is the nominal, but provided it is within 0.3 of that, and this is at 53.3, that is acceptable.
Number She said last.
Therefore, take off that switch position.
Let's go now.
Reset these switches and come down to the tank 11, which is in the back of our fuselage, to make sure that we've got approximately the correct amount of fuel, which we have, and then set the load limit controller for the amount that we will need for our cruise activity to bring the CG back to 59% for supersonic cruise. We're now taxiing forward, and we have a suitable speed so that I can check that the anti-skidar lights are not illuminated, that they are not. The next item is what we call a reverse air shutoff check. This checks our protection on our secondary nozzles and reverse buckets on the back of our engines. It makes sure that if we're in reverse and for some reason the engines are not giving us reverse but giving us forward power, that we cannot apply the power. It also ensures that the buckets do not run away in the wrong direction. We make a check at this stage to make sure that that is functioning correctly. Reverse air shutoff check, Dave.
So you're going all the way round to there.
Understood. Roger. Say again?
Reverse air shutoff check.
Yeah, go ahead.
Mid-travel forward. I'm looking at this panel up here to make sure that the wind-down lights have come on. Idle. Reverse idle. The buckets have started to move and have been stopped by the protection system and cancel. And then everything resets back to its normal position. The wind-down lights are out, and the secondary nozzles have gone back to their nominal position of 21 degrees, which is normal for takeoff. Seats and harness next.
Lock power secure.
Lock power off and secure.
Having secured our harnesses, we now go back to the checklist, and in this case, we get to the item that we actually did slightly in advance, was to make sure that we got the right fuel in tank 11. Having done that, we then have to select a number of switches. The tanks are very fuel, and as we actually accelerate and climb, we need to exercise the fuel in a way that we call a de-air, and we then put on a number of pumps to do that. One in tank 6, one in tank 11, another one in tank 8. We actually put 2 on in tank 7A, 1 in 10, and 2 on in 5A. We then check the takeoff CG switch. Takeoff CG switch.
Should be normal, looks like it is, 53.5%.
53.5, Dean.
And both our pilots have now confirmed that they have the same CG setting as I have back here. We then have to turn on the main transfer pumps. First in tank 5, and then in tank 7. Now these pumps feed into our main collector tanks that feed direct to the engine. So as we take off and use fuel from the collector tanks, it is replaced by fuel from tank 7. We already have the report from our cabin service director, so the taxi check is complete, Dave.
Thank you very much, Roger. Well, the taxiways are quite busy today. There's quite a lot of traffic around. It's taken us quite a while to get away from the area of the British Airways terminal because there was quite a lot of inbound as well as outbound traffic there. And we're now moving our way around towards the runway, which is away on our right-hand side still. And just moving out onto one of the outer taxiways. And as you can recall, when we look around the outside of the aircraft, the nose wheel is some 37 feet behind where we're sat. And so we tend to go out beyond the point we want to line up with before we start turning the aircraft round. And then the nose wheel and then the main wheels follow us round, and we finish up lined up on the centre line we were aiming for. Steering the aircraft on the ground with the tiller stand by my left hand. My left hand's doing the steering. It actually just steers the nose wheel hydraulically. While we taxi the aircraft, we're also quite conscious of the temperature of the brakes, and so Roger monitors the temperature, and I can actually see the gauge by turning back and looking at it over here. What we obviously don't want to do, therefore, is be sitting with our brakes on, just moving forward slowly all the time. It's far better to get somewhere, stop, and then put the brakes on. If the brakes overheat before departure, then we can't take off with the brakes. We have to let the fans cool them down before we can go.
120 degrees is the hottest, and they're relatively even.
Thank you, Roger. Roger's also able to tell me which side, if one is hotter than the other, so we can actually bias the amount of force we're in on either my left foot or my right foot. You can actually steer the aircraft while you're taxiing by using the rudder as well. There's a limited amount of rudder control for steering, as well as using the tiller. There's two tillers, one on the right-hand side when the pilot in the right-hand seat is flying the airplane. And of course he has duplicated brake systems and rudder systems as well, so we've got plenty of backup to support any failures we may have. Quite close to the runway now. There's a lot of traffic on the right-hand side waiting to go. They're departing from an intersection a little bit further down. As I said earlier, the part of the runway out on our left-hand side is actually closed while work is being done on it. It's a very long runway anyway, so what's left is still longer than most airports have. But for us, we need to go from the intersection which is just ahead of us, and air traffic control are aware of that and are going to give us our clearance to go from that intersection. It's quite hazy out there, but when we take off, you remember from the chart in the office that we'll be actually heading towards Manhattan, if you like, some distance away from us, of course, turning left just after we get airborne. Although with the rather hazy atmosphere, I think we're going to not see anything of Manhattan ahead of us at any stage during the departure. Before takeoff check, please.
Briefing takeoff data.
Right, no change, just to confirm 5,000 feet the first block, 3,000 the safety height, and we are a stopper.
That's understood. Landing lights.
Taxi turns are on, the rest are off.
Transponder.
Set.
Wheel lights.
Off.
They're off here. Hottest is 100. Master warning.
Recalled. Clear. Inhibited.
Takeoff monitor.
On.
Reheat selected.
4 white.
Checks on. Pitch index.
13.5. Cross check.
From 10, cross.
Seabird 2 Heavy, runway 31 left.
Radar.
Some kilo, clear for takeoff.
No, thanks.
31 left from Kilo, clear to takeoff.
Before takeoff check complete.
Thank you. We've just, in fact, been given our takeoff clearance, which means that they got their number in the queue wrong. So we'll be just lining up on the runway, getting airborne in just a few seconds' time. Everybody sat down back there?
A-firm.
Thank you. All set to go, Roger?
Yes. Checks complete.
Set. Brakes are released. 3, 2, 1, now.
You can fly 991 Kennedy Tower, runway 31 right, wind 2408.
Airspeed building. $100 knots.
Power set.
You can fly to 831, just hold short of the runway. Hold short.
P1. Rotate. P2. Positive climb, turn.
Gear up, please.
Gear.
Seabird 2 Heavy, contact your departure now.
So long, Seabird 2. 3, 2, 1,
You can fly
noise.
831, wind 2408. Caution wake service, departed heavy jet, taxi in position and on. Position and hold, legal 831. I'm sorry, just airborne the call sign again. S26 uniform Romeo.
Sergeant, good morning. Speedbird Concorde 2 is climb is cleared, 5,000 feet.
Alright, stand by 260 uniform Romeo, New York, fly heading at 260. 260 uniform Romeo.
10 degrees to go.
Concorde 2 Heavy, near departure, radar contact, climb maintain
235.
13000.
Climb maintain 13000, Speedbird 2.
We have 091 Heavy, contacting at departure, 124.75, good afternoon.
And the up to takeoff check, please.
3,000.
3,000 feet, thank you.
13 checks.
Up to takeoff check.
Landing gear.
House lights off and neutral.
Landing lights.
Taxi turn still on.
Master warning.
Recalled.
Good morning, departure, winds 2167 Alpha, we'll get 5,000.
7 Alpha, get that ground, Kenny, altimeter 3013.
Speedbird 2 standing by heading.
Seabird 2 Heavy, turn left in 130. 67 Alpha, Kenny,
Regulars,
altimeter
130
3013,
sets.
over.
Checks.
We got the altimeter
approaching 2,500 feet.
Okay, the radial's active.
Thank you. A bit more bank on now.
1 dot to go.
That'll be okay on the radial.
Too heavy, 1 able for direct ship.
Air nav ship, Beaver 2.
Throttling.
Okay.
Getting out to Miss
Direct ship now then, so
Yep.
that on the INS, thank you very much. Coming up towards 5 miles. My throttles.
You have them.
And you'll Beaver 2 on course ship, okay, with 3 speed.
Out of 5,000 feet, that's good.
Broadcast Beaver 2.
And the nose and visor up, please.
Okay, check. No. And the visor.
831, we're on a direct
Nose and visors up and locked after takeoff check is complete.
Thank you very much. Do 5,000 increase that, sorry.
Roger, copy,
Seabird 2, heavy contact, New York Center 134.55, you there?
13455, Beaver 2, thanks for your help, bye.
Thank you. After takeoff check complete, is it, Roger?
Affirmative.
Thank you very much.
Neil Sender, good morning. Speedbird Concorde 2, climb is cleared 130 on course ship. Climb maintain 15,000, Speedbird 2. 15,000.
Checks.
So we're climbing now through 6,000 feet. Kennedy is some 10 miles behind us, just accelerated through 300 knots. Up to our normal climb speed, which will be as near to BMO as we can get. It'll be about 395 knots. We've been cleared up to 15,000 feet. I hope and anticipate what we're going to do is get a continuous climb before we get to 15,000 feet. They'll give us a higher level. We're just approaching a Mach number of 0.7, and when we do, that'll be another trigger for an item on the checklist, and Roger will be going through that checklist in just a few seconds' time.
Okay, that's 100, climb 1.
230 on. 20R92 is set. That was a climb check. It's now 10 for 23 with the prime.
That's up.
At 0.7 Mach, we start to move the fuel rearwards. As you can see from these two amber indicators, they indicate the fore and aft limits and are governed by the Mach number. This one has started to move rearward, and we now have to move the centre of gravity to keep it between the two. I select rearward movement, remove the de-air pump from tank 11, and we are now in a position where the tank 9 pumps are switched on. Fuel is transferring through the aircraft into tank 11 through these inlets, and the gauge should start to increase. The fuel is moving rearwards, Dave.
Thank you, Roger.
We also confirm that the takeoff CG switch is in the normal position. We've now finished with the brake fans. We don't need them anymore until we come into land, so we actually turn those off. We also had the engine control schedule set to flyover to minimise the noise during our takeoff. We can now select it to normal in preparation for our supersonic climb. The flight deck door switch is selected to normal, and we check to make sure that the seatbelt sign is switched off. Taxi turn lights.
They're off.
Thank you. The climb check is complete. The fuel is running aft.
Thank you, Roger. Altimeter check, please.
Okay, 200 up to 230, that's prime. 2992 set, and 53.8 going off.
Checks. What we now have to do is to monitor this CG position. It's very important that we keep it within these two amber indicators. And it's moving rearwards at the moment, but we're also continuing to accelerate quite fast. And therefore, these two amber indicators are going to move down the gauge. They will actually be down here at about 59% when we get to Mach 2. But at the moment, the forward one here is starting to catch us up a little bit. But the CG is moving aft. We're now back to 54%, and we're looking for 55% by the time we have to level out subsonic if we do. We've in fact been given our clearance up to 60,000, so we're going to go straight through. So I will leave this CG operating in a rearward direction right the way through our climb now, monitoring it and checking it at various stages as we go along, using the checklist. We're fast approaching our transonic acceleration, and I need to make sure that the other checklist items are actually ready for our supersonic climb. We have the auxiliary inlets that we check to make sure that they're all in the shut position, and that our secondary nozzles, the reverse buckets on the back of the engines have started to move towards the zero position. About 11 degrees is the optimum position at this point. On the checklist, I'm now standing by for Dave's command for the reheat.
Sonic check complete.
Standing by the reheats.
Okay, 0.91. We've got our clearance, 60,000 feet.
Checks.
And we're just coming up towards 0.92. Approaching 0.93. We'll do it on Les's side. 2, please.
Selected.
And the other 2.
Selected. And I've started the stopwatch so that we can keep a record of how long the reheats are used at this stage. We then come back to the fuel transfer to make sure that we are still transferring aft, and at the moment we're 54.8 and it is going in an aft direction. Tank 11 is starting to fill up, and the nominal full value for Tank 11 will be 10,500 kilos. When it actually gets to that stage, these 2 inlets will close and we will start transferring fuel from the front of the fuselage out into the wings on either side through these inlet valves. We're now through 55.1 on the CG, and you can see these amber bugs are still moving rearwards down the gauge. 55 is the normal subsonic cruise centre of gravity, but because we're accelerating through, we're keeping the fuel running in a rearwards position. We've just come through Mach 1, and well, there's some more checklist items to do at that stage. Pressure static heaters, which are our heater plates for the static vents on the outside of the aircraft. The heaters are no longer required. As the Mach number increases, the total temperature, the skin temperature increases, so artificial heating is no longer required in that area. We confirm that the engine anti-ice are in the off position, and that the wing and intake de-icing is also on. Transparency de-ice demissed.
Okay, they're all off, Roger.
Okay, and we're just now, as Roger said, going through Mark 1. We're just 12 and a half minutes away from takeoff, so we're just 12 and a half minutes to get supersonic. And the outside air temperature again today is still actually quite warm by comparison to the standard atmosphere. So we're going to find a slightly slower acceleration. It's going to take us a little bit longer. This will affect our performance again, but we'll be covering the ground at the same sort of speed as we should be, and we won't lose too much time on this.
30.
30, yeah. 60, no prime, 55.8.
Checks it's still going aft.
Yep. So we've just gone through 30,000 feet, Mach 1.01, and accelerating all the while as we set off across the Atlantic.
We continue to monitor our centre of gravity position back on the engineers panel at this stage, and we note that we've actually filled up the Tank 11. It's got to its nominal full value, and the inlet valves have actually closed.
Yes, they're at 1723.
The inlet valves for 5 and 7 have opened, and we're now pumping fuel out into the wings. Because we finished with Tank 11, I can now reset the load limit controller and back to a much lower figure. We have a subsonic section to fly going into England, and the approximate fuel needed in Tank 11 at that stage is 3,000 kilos, and I'll set that in this load limit controller. We're still pumping from Tank 9, which is primarily in the fuselage right at the front of the aircraft, through into the wings, and the centre of gravity is still moving aft at 56.1%. It is now ideally positioned right in the middle between the forward and the aft limit bugs.
And 1.1, Roger.
Roger, and 1.1, we only have one item to check, and that is our secondary nozzles, the reverse buckets. By this stage, they should be into the zero position, giving us a Concorde nozzle, and from now on, as the Mach number increases, we will start to get thrust from these buckets. They are all in the zero position, so I can confirm to Dave that the secondary nozzles are checked, and the CG is 56.5, still moving aft.
Thank you, Roger. 56.5 checks.
On the ground, number 3 air conditioning unit was not working correctly, and we switched it off. Now that we're accelerating and up to 34, coming up for 35,000 feet, it is an opportune moment to reselect it to see whether it will now work correctly. These air conditioning units and systems are very susceptible to low speed, and it is quite likely that it will now work perfectly well. The switch I am got my finger on at the moment changes the sensing if we lose an air conditioning system. So I'm going to select that back to normal, and you can see that the temperature control valve has gone full hot. The reason for that is that there's very little air coming through the system at the moment as the valves open up. As the air passage increases, this temp control valve will then come back to a more normal position. There we are. And at the moment, that air group is looking quite reasonable. I'm going to open 2 of the cross-bead valves to put a little bit more air through that so that it shares it with the next group, and we'll see how that goes. In fact, you may even be able to hear the increase in the air noise on the flight deck, because there is actually much more air coming into the aircraft now than there was before. We've also now got to the stage where we've just about emptied tank 9. That's the one in the front of the fuselage. Directly behind it, partially in the fuselage and partially in the wings, is tank 10. That had nearly 11,500 kilos of fuel in, and we're now transferring from that tank out into the wings to 5 and 7. Because we've completed the work with tank 9, I can select both the pumps off for tank 9. We check again our centre of gravity, and we're now back to 57.2, well positioned between the 2 limit bugs. We're now looking at our next trigger, and we are in fact at Mach 1.3. This is the point at which our ramps start to operate within the intakes. Up to 1.3, the actual configuration of the intake slows the air down before it goes into the engines without any action from the ramps. But in this case, as we've gone through 1.3, the computer-controlled ramps have started to operate, and they've come down to about 8%. That's 8% of their full movement. We expect to see them in around the 40% position for our Mach 2 cruise, and they will gradually come down as we accelerate. We have, for each of these ramps, 2 computers that can control them, and they are selected from this position. Should both computers fail, we have in fact the ability to control them manually. So we have a number of different means of achieving the same motion with these ramps. We've continued to accelerate, and we're now up, just coming up to Mach 1.5, and you can see that these ramps are continuing to move down slowly. They were at about 11%, they're now down to 20% and continuing to move. They take into account the engine rotational speed and also the forward Mach number of the aircraft, and also the actual density of the air. And the computer computes all that information and decides at the optimum position to place the ramp to create the pressure wave within the intake to slow the air down.
Approaching 1.7, Roger. Stand by the readings.
Standing by.
Inboards off. And the outers. Thank you.
They're off. 10 minutes 34 seconds on the reheat.
Thank you. AFCS checked. And that's the 58.2. And that cross-checked. Thank you, Roger.
We've now got to the 1.7 Mach trigger on the checklist, and on our captain's commands we've taken off the reheats in pairs again to minimise the effects that they have on passenger comfort. We have also asked for the autopilot flight control system, the AFCS, to be set up for our cruise regime, and Dave has confirmed that he has done that. We go back to our fuel at this stage to make sure that we're still transferring the fuel aft. We're now back to 58.3 on the CG, and you can see this indication here. The forward and aft limit bugs have moved virtually as far back as they're going to go. This aft bug is now at 59.3, which is the aft limit. The forward bug will come back a little bit further, but not very much. We're still transferring fuel from tank 10 out into the wings 4, 5 and 7. During this checklist process, we in fact have to monitor the whole of our panel. And we do that by carrying out a panel scan at regular intervals. If something is abnormal or different to normal, then we will note it and look at it and investigate it should it be necessary. Because we've got 4 engines, we tend to have banks of gauges that are 4 together. And in fact, there's a set of engine instruments just here. And there are 4 sets, one for each of the engines. It is not our practice to look at each individual gauge. We would scan diagonally across them. In so doing, if one is different to the other 4 that are indicating the same parameter, it will stand out. And then we would look at that specifically and decide whether there is a difficulty or whether it is normal or whether we have to do anything about it. As you can see from these instruments, they're all virtually the same and indicating quite nicely for this stage of our flight. CG starts to get quite critical at this stage because when you get to 59%, there isn't a lot of leeway for the CG position. And we're now back to 58.7, still moving aft, and you can see that it's running back towards this aft limit bug.
Having switched the afterburners off, we're now climbing and accelerating a little slower, but already it's Mach number at 1.85. We're 46,500 feet. The outside air temperature, that temperature that affects us so much all the time, has actually got cooler in the latter stages of the climb. That was the slight rumbling that you may have sensed. That's probably as we went through different layers of temperature, a little bit of wind change as well. It's quite cool outside now. It's got down to minus 67 degrees Celsius. That's quite a bit colder than the standard atmosphere. That's giving us quite a bit better climb performance at this height and weight than we had yesterday, when it was really quite hot coming out of London. So we're climbing at about 700 feet a minute at the moment, and still accelerating towards Mach 2.
We've now reached a CG position of 59%. That is our furthest aft CG that we use during normal flight. You can see that it happens to coincide today with the tank 10 being emptied, and this is indicated by the 2 low pressure lights coming on. I can now remove this switch back to its normal position, and that will automatically turn off the tank 10 pumps. The de-air is no longer needed in tank 10 because there isn't any fuel in there. So at this stage, we have fuel in the rear of the aircraft, 10,500 kilos, back in the aft fuselage. All the rest of the fuel is either in the left-hand wing or in the right-hand wing. Now at this stage, we've also got fuel right in the wingtips. We have here a tank 5A and also a tank 7A. They are right in the wingtips, and they are left full until this stage of the flight to stop the wing bending moments getting too great. We've got through that stage of flight, so I can now take fuel out of here. I do that by opening the valve. The pumps were already on for de-air purposes, so I've opened up the valve on each side. That, however, starts to change our centre of gravity, because these 2 tanks are in our wingtips and we're transferring it forward. So to counteract that, we operate an aft trim system. I select it at this point, it indicates aft there, and then when we look at the collector tanks across here, although this panel is set out in what appears to be the shape of the aircraft, it isn't quite the shape of the aircraft. This tank and this one, that's number 1 and 4, are positioned much further up the aircraft. So what is going to happen now is as we use the fuel from the wingtips, we are going to reduce the amount of fuel that is in the collector tanks that are further forward, and one counteracts the other so that the centre of gravity will actually stay static at 59%. We can now go back to our checklist activity, and one of the first things that we have is the fuel tank pressure. This doesn't work until we get up to about 45,000 feet. At the moment we're 49,300 and climbing, and you can see that we've got just under 1 psi of pressure within our tanks, and that is normal for this stage of the flight. We've also finished with the other de-air pumps, so we come back to the fuel panel. I've already turned off the one in number 11 because we were transferring fuel from there. I've turned off the one in tank 10 because there is no longer fuel in there. The ones in 5A and 7A are actually being used now to transfer fuel, but the two, one in tank 6 and one in tank 8, are no longer necessary, so we can turn those off. We also set up the fuel panel in case we needed to do an emergency descent, and we do that by moving the tank 9 and 10 load limit selector and setting 8,000 kilos. I'll explain to you a little later the significance of this and why we do it, but it is part of our checklist operation at this moment to set 8,000 kilos in the load limit controller. We've already started off 5A and 7A, and we've therefore got to the point on our checklist where the next item is 50,000 feet.
So here we're just approaching 50,000 feet now. Just about to establish at Mark 2, twice the speed of sound. 50,000 feet of Mark 2 just about coming almost exactly the same time, and at that point I'll ask Roger to select cruise power, and the autopilot will start to latch into our cruise phase. Thank you very much.
Cruise is selected.
Thank you. Cruise is selected. Just gone through 50,000 feet for 60,000 feet with a CG of 59.1.
It is static.
So having just gone through Mark 2, gone through 50,000 feet, the automatic flight control system, the autopilot up here, has now switched into our cruise mode. And basically this side of the autopilot is giving us our vertical profiles, vertical speed, indicator speed, glide slope and so on. And this side of the autopilot is giving the navigation, heading control, INS control, control through the inertial navigation system. And the section in the middle is the basic engagement mode of the autopilot. And of course, the auto land selection. This aircraft can do auto lands right down to very, very low visibilities and cloud bases. If at some stage the air temperature gets so cold or the speed gets a little bit too high that the pitching motion can't actually control the speed increasing, then the auto throttles on this side here, which are latched in a standby mode normally in the cruise, are engaged by the autopilot, and they pull the throttles back just a little bit to contain the speed. Then once the speed has been contained, the power is put back on again. The autopilot at the same time pulls the nose of the aircraft up just a little bit and says thank you very much to the auto throttles, which then switch themselves back into the standby mode. In fact, there they've gone now. The autopilot holding us is in this max climb, max cruise mode, and the auto throttle light has gone out to say it's now in the standby mode, the switch is engaged, it's in the standby mode. Should the autopilot need it, the autopilot will ask the auto throttles to help it control the speed. And this is the basic mode through which we'll operate now for the rest of the flight until we're ready to start our deceleration and descent. All the while the computer of the inertial navigation system is feeding its information into the autopilot and providing Les and myself with the correct information into the inertial navigation system. It'll feed it through to the autopilot and navigate us across the Atlantic. The outside air temperature is actually helping us quite well today. If you remember yesterday, it was actually quite warm during the climb. And today it's at 6 degrees below the standard performance atmosphere, so that actually gives us quite a help with the performance of the aircraft. It's actually quite inhospitable out there, nevertheless. It's minus 63 degrees Celsius. If I was to step out on the wing like I did a couple of days ago while we were in the maintenance area, it would actually be extremely cold out there. But the skin of the aircraft is beginning to warm up, and the temperature on the nose of the aircraft, the hottest point on the skin, at the moment is plus 107, plus 107 degrees Celsius. And back where I was stood on the wing of the aircraft, it would be comfortably in the 90s out there on the skin of the aircraft. We're also stretching, of course, and the aircraft is now about 8 or so inches longer than it was on the ground. Well, we settled very nicely into our cruise climb, 51,500 feet. Hardly climbing at all at the moment, but a nice steady speed of just a little bit over Mach 2, twice the speed of sound. Our speed over the ground, over the ocean at the moment is 1,310 miles per hour, 1,310 miles per hour, well over 20 miles a minute. We've been checking our fuel figures, and despite the fact we used more taxi fuel than we anticipated originally, we had that extra fuel on board. We didn't use all of that. and we checked the fuel figures. We have got all the necessary reserves that we need for a normal flight, and our planned ETA at the moment for London is 6:23 in the evening local time, 6:23. That's going to make us a little late, but that's due to the problem we had with the baggage on departure and of course the weight we had for takeoff. What we're able to do is relay ahead to our company any special messages from passengers, and if any of our passengers have problems with that time, with the slight delay on onboard connections, then we can ask our company to set up alternatives for them, and they'll be met when we arrive and help through the system to catch their connections if they're going on a connecting flight, if they happen to be quite close to the arrival time. Cabin crew will be doing that with them and getting any information from them during the flight. Meal service has already started. They'll be enjoying some champagne back there. I think it's a little caviar to start the meal with, and they'll be eating through the next hour and a half or so, and we should be arriving in London, at least we'll be on the approach, dependent on air traffic control, any delays they may have there, in about 2 hours and 35 minutes time.
Throughout the supersonic cruise, we have to monitor the CG position in exactly the same way as we did while we were climbing. We're now 43 minutes into the flight, and we're in a position now where we had started the A tank so that they would feed into their associated wing tank, and we'd also started the collector tanks, the two at the front of the aircraft, 1 and 4, coming back to a lower level to counteract the CG movement between the two. The CG is now 59.1, just about 59%, and you can see we've nearly emptied tank 5A and tank 7A. At the same time, tank 1, which was at 4,000 kilos, and tank 4, which was at 4,000 kilos, has reduced to 2,500 kilos, 2,500 kilos. Those two have counteracted each other, and when 5A and 7A are empty, we expect to see 1 and 4 at about 2,000 kilos. They will be then controlled at that level until I need to release them to fill them up because of wing temperature considerations. The CG is operated primarily for the phase of flight and the Mach number. However, there is another consideration with the fuel on this aircraft. It is used for many other items, not the least of which is cooling our engine oil, also cooling our air conditioning system, but it is also used to cool the wing structure in a very set pattern. This set pattern was devised during the flight test and the ground testing before Concorde came into service, and I have certain triggers on fuel levels in particular tanks that require me to take action, which we will show you as we go along, that is there purely to keep the wing temperatures within the necessary limits. Now we're fast approaching the point where I'll be able to switch off the pumps in 5A and 7A, and we will see that 1 and 4 are down to 2,000 kilos. Before we can fly the aircraft, we have to decide on the fuel, which you saw us doing during our pre-flight briefing. When that is complete, we notify the ground engineers who are going to refuel the aircraft. If we're at a place where we haven't got any qualified ground engineers, then that would be the flight engineer's job. What we do is get a refueling book out, which has got schedules of refueling tank figures that are dependent on the density of the fuel. Now, the density of the fuel at New York was 8.805 kilos per litre. So we would actually go into the refueling tables and find the amount of fuel that we were using, which was 90,000 kilos. We would then go across the page, picking up the individual tank figures. Now, most of the tanks will be full, but in this particular case, tank 10 wasn't quite full, tank 11 wasn't quite full. That would allow us to set up the refueling panel to give us the precise amounts of fuel in each of the tanks. We also go through a refueling sheet, which initially has the incoming fuel figures. We then take that figure against what we need. We then convert that from kilos into litres, and we use further pages within this manual to get the necessary figures for that. And the reason for that is that our refueling tankers deliver in litres. So we have a calculated amount that we require, and the one below that is actually the amount delivered by the Bowsers. And we have to compare the two, and they have to be within certain limits to be acceptable. We also write down here the actual fuel figures in each of the tanks. When this process is complete, and I as the flight engineer have checked it all, we transfer some of these figures to our technical log. The aircraft maintenance log is actually an up-to-date history of the aircraft and its technical state. Right in the front of the technical log, it gives us an indication of the oil that is being used by each of the engines for the sectors that we fly. After that, we have a history that is filled in on each of the flights, noting the defects and also noting the engineering work that has been done by the ground engineers at each of the stops. Now obviously there is a lot more in here for Heathrow than there is for anywhere else, because that is where most of the engineering is done. For each sector that we fly, we actually fill in one of these pages. You can probably see now that I have two lights flashing at me on the fuel panel, and that's telling me that tank 5 is now empty. So I turn off those pumps, select on the pumps for tank 6, and then on the other wing I'm doing exactly the same with tank 7 and using tank 8 pumps on. Now this sheet that we have in the tech log is filled in for each departure. It gives the information on the flight that we are going to do. It gives the incoming fuel figure. It tells us what the engineers have put into the engine oils and also into the hydraulics if it's necessary. The figures that we have transferred from our refuel log are placed here, and then the tech log is presented to me for verification. Having done that, I pass it on to our captain, because he then has to accept the aircraft from the ground engineers, and provided he is happy, he signs it here. Now for this sector that we are now on, we would then go over until the next page, and I would then fill in this particular page with the information along the top concerning the flight we're doing, and then down here, any defects that occur on the flight. At the end of the flight, I fill in the fuel remaining and pass it up to the captain, who will then sign it. The technical log also has a number of other things contained within it. If we have performance problems because of defects, they're always annotated here. And as you can see, there are two here, but they've actually been cleared. So at the moment, there are no performance defects applicable to this aircraft. These are what we call deferred defects, acceptable deferred defects, and they indicate things such as brake temperature sensors that have been used, and you can see there are one or two that are still valid. The blue pages, in fact, indicate the regular checks that are required on the aircraft, and the engineers fill them in as we go along. Towards the back, there is a supplement which tells us specific things about engineering activity that has been undertaken on the aircraft, and also the type and state of modifications that have been incorporated. So this technical report gives us a complete history of what has happened to the aircraft in the recent past from a maintenance point of view, and also tells us its current state. While we're in supersonic cruise, we're going to take the opportunity to show you a number of things around our panels. First of all, the engineers panel can be divided into two areas. One that is below the basic table and the rest that is above. What is below the table only gets used in abnormal circumstances or for test on the ground. So we're going to concentrate on what is above the table. Starting up here at the front end of our panel, you will remember that during our look round the outside of the aircraft, we operated the nose and visor and also the flying controls. This meant we had to operate the hydraulics. Now, we hadn't got any engines running, so we had electrical pumps that gave us that hydraulic power. They are controlled from this panel. This particular panel has a number of things on it. Firstly, a clock. Secondly, an indication of our brake pressure. We also have an indicator for the brake overload, and the sensors for that were down on the undercarriage, and also the brake fans. You will probably have heard us referring to brake temperatures as we've gone along during the taxi, and this is the panel that shows that. And if I press an individual caption here, it will tell us the brake temperature on that main wheel. The panel immediately below that is dedicated to our intakes. Firstly, we have a number of warning lights in case we have malfunctions with the computers or any of the other intake activity. We then have the selectors, which allow us to select the particular computers. Now, if we do have a problem, and we have difficulties with the hydraulics or with the computers themselves, we have the ability to either control the ramps manually or to select to other supplies for the hydraulic power. These selectors are the ones that are used to select the other hydraulic systems. This selector here, which is guarded, allows me to isolate the two computers that are controlled from here and to then operate the ramps and the spills in our intakes manually using these two switches. You've heard us talk about the fact that the intakes set up a pressure wave. We've actually got an indication of that pressure wave, and it is at the top of the intake panel. The intake pressure ratio error gauge shows us the approximate position of the pressure wave. You will find that it moves around slowly as the temperatures change and the engines change slightly under their electronic control. But basically, it's got two amber bands. If this needle gets into the amber bands, then the pressure wave is in the wrong position, and we're going to have to do something about it before it causes the engine and or the intake to react. That's the intake panel. We then go back up to the top of our panel again. We have here the control of our pressurization. We have two systems. Either one will do. At the moment we're actually operating on this one, and what we do in this case is we set into it the altitude that we wish the cabin to climb to, which is about just under 6,000 feet, about 5,500 feet. It's actually indicated here, and you can see that says 5,500 feet. The differential pressure between the inside of the cabin and the outside of the cabin is indicated by this indicator here, which is showing 10.5 pounds per square inch differential pressure. When we looked at the outside of the aircraft, we saw the discharge valves. They're indicated by this selector here and this indicator here. The rest of these controls are tended to be utilised for abnormal situations. Our drills require us in failure cases to use some of the other bits and pieces that are up here. But normally this panel is operated from this controller here. Below the pressurisation, we have an area that is dedicated to secondary engine instrumentation and control. These are all warning lights of one sort or another, which we don't normally expect to see in flight, but occasionally they do come on. If they do, we would then have to get our abnormal drill out and undertake the requirements of the drill to rectify the situation. We have fuel heaters in our fuel system. We have recirculation valves. Now, these recirculation valves are there for a very specific purpose, and you will see them being used during the deceleration. We use fuel to do a number of things, as I said earlier, one of which is to cool the engine oil and various other bits and pieces. When we throttle back for the decel, there is insufficient fuel going through the system. So we open these recirculation valves, which allows us to increase the rate of fuel motion, but some of it is actually returning back towards the tank system and then being used again. The 88% switch is associated with our number 4 engine during the takeoff roll, where we hold it at a slightly lower RPM until we get to about 60 knots. The high-low switches are to do with our engine idle. Below that panel, we come to further engine instruments. These are what we call secondary engine instruments, and they indicate the temperature that we have for our TCA. That's the turbine cooling air within the engine. We also have a fuel temperature indication. We have an oil pressure indication, oil temperature, and oil contents. And there are 4 sets of instruments for the 4 engines. Below that, we have what we call a P7, which is a pressure indicator, which shows us what power the engines are developing. And British, European-made engines, we tend to measure in what we call P7, which is a pressure. The American-manufactured engines have a slightly different system of indicating the amount of power that they can develop. Finally, in this part of the panel, we have the fuel pressure indicator, and that's now indicating a fuel pressure in our tanks of 1.5 psi. That is normal, and it will fluctuate and vary as we climb and we descend, and you can see that it has colour codings which indicate to us the areas where we would need to take action if it got into the amber bands. We're now looking at an area of our panel which controls the air bleed and temperature control in the cabin. Again, it's done in 4 sections, one for each of the engines, and this is a direct feed from the engines themselves. Air is tapped off of the engine and fed through this system. We then have to put it through various coolers, exchangers, to present it into the cabin at a very cold level. At the moment, if we come across onto this panel up here, you can see that the duct temperature, which is the temperature of the air coming into the cabin, is just about on freezing. That needs to be so supersonic because the skin temperature is very warm. We therefore have to bring cold air in. These indicators show us the amount of air that is coming into the cabins, and the 3 indicators here show us the temperature that we have in the cabins. This one the flight deck, this the forward cabin, and this the rear cabin. The temperature control is undertaken from here. It is automatic, but if the automatics don't work, then we can come to what we call a standby system, which allows us to control the temperature manually. This panel here is the equipment bay cooling panel. Again, because everything gets so hot in this aircraft, we have to send tremendous amounts of air through our electronic equipment to keep them cool. And this panel is what controls that. We have a lot of electronic equipment at the front of the aircraft, but we also have some down the back. So we have a system that deals with the front of the aircraft, another system that deals with the rear. And we can supplement the forward ones by supply fans as well as extractor fans. This indicator shows us the amount of airflow going through the system in the forward area. That takes us back to the fuel panel, which is this very large panel here. Concorde has 13 fuel tanks. They're numbered 1 to 11, and then we have 2 A tanks. One of the things that we have to watch as we go along is our elevons, because if we get a difference between the elevons from one side of the aircraft to the other of about ½ degree, we can actually increase the fuel usage. Now there is a slight discrepancy now between them, so what I'm going to do is to have to move fuel from one wing to the other to balance it. I'm going to take it out of the right-hand wing to put it into the left-hand wing to balance the system. First thing I do is tell Dave, transferring across the ship, Dave. Because we're feeding into the collector tanks, the way that we do this is to actually use a jettison valve, which is also used when we jettison fuel overboard. But in this case, it's taking it from tank 3 and putting it into this manifold that goes the length of the aircraft. I do that by opening the panel here and selecting the jettison valve open. Number 3 is now showing open. I then have to put it into tank 11, so I select the inlet valve for tank 11. Then got to take it out to get it in the other wing. Open the inlet valve for tank 5 and put the pump on in tank 11. And there is now fuel moving from one side of the aircraft through the back of the fuselage into the other side. And that's going to balance up the elevons so that we don't create extra drag. It's actually a very quick process because the transfer of this fuel is extremely fast. We have very powerful pumps. In fact, I've actually transferred enough now, so I can now close the system. Now, I mentioned earlier on in the checklist that we set 8,000 kilos up in tank 9 on the load limit controller. That's the tank 11 load limit controller, and the tank 9 load limit controller has got 8,000 set in it here. That is in case we need to go down at a considerable rush, an emergency descent. If there were mechanical failures or computer failures, or even if air traffic required us to come down very quickly, we can actually go down very fast indeed. But to cater for that, as we go down, these forward and aft bugs will move up the gauge, bringing the CG forward to keep it in between them. And to do that, we have to transfer from tank 11 forward. I may be very busy with abnormal drills at that stage, so Les, our co-pilot, has a switch that will allow him to move the fuel from tank 11 to tank 9 in those circumstances. And this load limit controller is set up ready for me to take control of the fuel back again at a later stage. The fuel panel is a continual operation. We're always playing with the fuel panel, moving things around. It is a very comprehensive panel that allows us to move fuel from virtually any tank to anywhere else. If we can now move from the fuel panel up to our hydraulic panel, which is up at the back here, you will see that we've got 3 hydraulic systems: green, yellow and blue. Green and blue are the 2 major systems. Yellow is effectively a standby that we can select as required. The difference on this aircraft is that we operate with a 4,000 psi system. Some military aircraft have 4,000 psi. Many, in fact, operate with 3,000, and virtually every other civil aircraft has 3,000 psi as the system. The reason we are using 4,000 is that we need tremendous pressure and ability to move flying controls. And with a 3,000 psi system, you had to have very large pipes. That adds weight to the aircraft. So rather than do that, we went for the 4,000 psi system, which allows us to have smaller pipes. Below the hydraulic panel, we come to the electrical generation system. At the top here, we have 4 generators, and this is indicating the outputs from them. The constant speed drive, which drives them through the gearbox from each of the engines, as indicated here, as far as the temperatures are concerned for the inlets, and also the differential temperatures. Again, we have 4 sets, 1 for each generator associated with each of the engines. And they are in a position where they can be coupled together. They also have automatic protection so that if anything goes wrong with these, it automatically switches the system. When you come down to this level, we come down to the DC side, and these are our 2 batteries. This is an integrated electrical system. That is in fact a very, very good one. We've already talked about our temperature. Next to it, we have a very interesting indicator. This indicates radiation. It was fitted to the aircraft before we started flying, because at that stage, very few aircraft flew at the levels that we're at, and only for short periods, and they weren't sure what the effect of radiation would be. As you can see, it's fluctuating around in the green band, which is completely normal. If it actually got round to the red here, due to sunspot activity, we would have to decelerate and go down so that we put more protection above us to bring it back into the green band. That's never ever happened in 21 years of operation. That covers virtually all of the engineer's panel, but while we're still on this panel, I just need to point out to you one other thing. One of the unique qualities of Concorde is when it's flying supersonically, as we've indicated, the temperature on the skin gets very high, and at the moment it's 123 degrees centigrade. that actually causes the aircraft to expand in length, and we're now between 8 and 10 inches longer than we were on the ground. Very few places will you be able to see that on the aircraft, but in fact you can here on the flight deck. This temperature causes this gap to develop that I can now put my hand in. As we will show you when we're subsonic, you won't be able to get anything in here at all. And that's really the only place on the aircraft that you can actually see the expansion.
I'm going to take the opportunity just to finish off telling you a little bit more about the flying panel in front of my position, and of course it's repeated on the co-pilot side, on Les's side of the aircraft. So we completed the description of the HSI, the horizontal situation indicator, and if we just move up to the left, first of all, a familiar instrument now, the Mach meter. As you can see, we can read the Mach number from the end of the pointer. We can also read it digitally, and of course at the moment it's reading 2.00. These two orange bugs on the Mach meter indicate the limits of our speed that we can fly in terms of Mach number, given the centre of gravity that Roger has set with moving the fuel around. And this way we can always make sure we balance the stability of the aircraft within the control forces available on the powered flying controls. So our aft position, we could slow down as far as this figure and still not violate the centre of gravity boundaries. This checkered needle there indicates the maximum Mach number that we're allowed to fly and indicate. So in fact, that's our limiting high speed factor rather than this forward bug. And at the moment, we're obviously very close to our limiting Mach number, which is just over Mach 2.02. The instrument above is our airspeed indicator, quite a big and very distinctive instrument. Again, we can read the numbers, the speed at the end of the needles on the scale round the instrument. And of course we have a digital readout of the same number across the top. And with the size of these digits, it's actually very straightforward to fly the aircraft to an accuracy of 1 or 2 knots or so. Again, we've got a black and orange checkered needle, which indicates our maximum indicated airspeed permissible at any time during the flight, throughout the flight envelope. Our VMO, in other words. And at this stage, we're a little bit back off that because we're actually cruise climbing at Mach 2. We're actually holding our speed now. This indicates that we could go a little bit faster, but of course we'd be actually violating our recommended and required cruise speed. So we're quite comfortable there, settling back on that. The maximum VMO we get is 530 knots. This is indicated airspeed, of course, so with the reduced amount of air molecules in the air, the thin air up here, that doesn't actually indicate our true airspeed. But an altered figure, which isn't compensated for with the density of the air. And the outside of the instrument, then we have a series of bugs that we can move around to set as aid memoirs for speed settings during the flight. So if we now move across from the left to the right-hand side, passing across the ADI, which we talked about earlier, we come to this group of instruments here. And the first one we come to is the vertical speed indicator, the VSI. And this, as you can see, is a strip instrument. The 0 position, no climb, no descent is across the middle there, and the light blue is a climb, the black is a descent. The orange triangular bug indicates our actual state at any one time, so at the moment, as you can see, just a slight descent at this stage in the flight. And on the left, the little white bug with a C in it is a command bug, and we have the facility to ask the autopilot to fly a particular rate of climb and descent, and by moving a switch on the autopilot, we can actually set that at a predetermined position, and the orange bug should line up with it as the aircraft performs accordingly. Some people consider this quite an unusual instrument, being used to more usually on aircraft round vertical speed indicators. But I think most people who fly this aircraft would agree that once they get used to this instrument, it's very easy to follow and in a very convenient position for our scans. Moving just to the right of that, we have the two altimeters, the basic altimeter, the standard altimeter that you see on many aircraft. Again, reading from a needle pointer around the scale and also a digital readout across the middle of the instrument. Very standard instrument, it has a normal function and also a standby supply in case the normal supply fails. And again, bugs are set on the outside to reminders of certain heights that we should be conscious of. In this case, I've preset this for our landing, and the first pair of bugs there indicates 80 feet, which is the height of the runway at Heathrow, and this one 280 feet, which will be our decision height, all things being equal on the approach. We're climbing again quite slowly, and again if you cast your eyes up to this instrument you see that ties in with a slight rate of climb on the vertical speed indicator. The little altimeter here is actually a radio altimeter. It doesn't come into operation until we're down below 2,500 feet, and it's really for the final 1,500 or 1,000 feet of the approach. A graduator scale around the edge of the instrument, as you can see. The needle will come out from behind this cover up there, and gradually as we get lower down the scale changes so that we can read very accurately every 5 or 10 feet towards the ground. And this is the altimeter from which the engineer calls the heights during the approach. He does this, of course, because sitting in the approach position, the approach attitude, with the aircraft pitched up quite high, we're actually here sitting quite a long way above the wheels, some 30 odd feet or more above the wheels, and this actually measures our height of the wheels above the ground and gives us an added amount of information as to know how far off the ground we are. Again, this bug, which is set here, is movable by this knob and is preset already for our expected decision heights on the approach into Heathrow. Just to finish in this right-hand corner, we have here also a standby artificial horizon. That's just the only one on the aircraft. There's only one on this side of the aircraft, and it's in case all the electronic ones fail. This gives us a basic amount of information on the artificial horizon. Now, if we move from there a little lower down the panel, we come down to this instrument here, which is another form of compass, but it's a radio magnetic indicator, which with the 2 needles on it, they can be tuned to medium frequency radio beacons, and they'll give you a magnetic bearing to beacons at any time that they're tuned and the signal is strong enough. At the moment, because we're still out over the ocean, they're not actually reading anything and just wandering around under random signals. And finally, as we move from the right-hand side, just coming into the middle there at the bottom, we have a side slip indicator. Again, a relatively unusual feature on large civil aircraft. That actually accurately reads from sensors on the side of the nose the amount of side slip, the amount of yaw that the aircraft is experiencing. And that's particularly important to us if we lose an engine, where the tendency obviously is to yaw, and we fly the little indicator in the centre to produce 0 side slip to make the aircraft most aerodynamically effective and to reduce the drag and to make it fly in its most efficient way. And if we continue then to move to the left, we have another radiomagnetic indicator. This time it's showing a compass again with needles tuned to VHF radio beacons, and again, because we're out of range of any, these are not pointing to anywhere in particular. These tend to be more accurate than the medium frequency and give us a pretty accurate magnetic bearing to any radio beacon that we're going to use. We can actually transfer that information in a even more accurate way back onto the horizontal situation indicator here, and this beam bar will move and actually give us a far more accurate reading of any centre lines or bearings that we need. And finally, moving right over to the left-hand side of the panel, a standby combined ASI and Mach meter, airspeed indicator and Mach meter. Again, a standby instrument in case the major instruments fail, and so the bugs are set up on there again. And from this rather complicated amount of numbers and digits on here, you can actually read the indicated airspeed and the Mach number should the main instruments fail. I also have on the left a G meter and an incidence meter. A very unusual feature on civil aircraft. A combined strip instrument with the G measure on the left-hand side, the little triangle indicating 1, as you would expect in stable, balanced flight. But it is to ensure that we don't exceed G, either as positive or negative readings at any stage during the flight. The right-hand side of that is an incidence meter, an angle of attack, if you like. And that basically is the flying instrument panel on my side of the aircraft. As I said, the co-pilot side, across on Les's side, basically the very similar instruments, a slightly different layout of some of the secondary instruments, but almost identical to my side of the aircraft. Top of descent check, please.
Warning landing displays.
Checked.
Briefing.
Just been told it's 27 left at Heathrow. It's 274 inbound, coming around via Ockham. Possibility of a hold at Ockham. It's inbound 332 right turns.
Yeah.
Standard briefing for a London arrival on 27. The safety height in the area is 2.3, and on the way down during the descent, it's 3,300 feet.
Okay.
Standard hand flow reduced noise approach.
Understood. Safety heights you've covered.
Yep.
4 to go. 3 to go. ASI bugs use 153 as a basic.
153, then 160 for
2 to go.
reduced noise, 163. Throttles at 160, please, Roger.
Throttling now. Altimeter bugs.
280 and 280 set on the altimeters.
What's that?
As we throttle for our deceleration, we monitor our ramps and spill doors to make sure they're reacting to the movement of the engines. And in fact, the ramps have come down and the spill doors are now also coming down, which is what we're looking for. Having throttled partially, we now go on with the checklist The first thing we do is open the recirculation valves to have more fuel going through the system, because the engines are using less now, but we need that extra flow for cooling purposes. The throttles we've actually already throttled. The aft trim we took off some time ago. We now take off the hydraulic pumps in tank 11 because we are going to transfer the fuel forward shortly. We are actually in a position where we have fuel in 1, 2, 3 and 4 tanks. Tank 11. CG has been brought forward to keep the wings cool and it is now 57.7. There is no other fuel in any of the tanks, only minor little bits and pieces. It is just these 4 and the big one at the back. When we get down to Mach 1.5, then we will start bringing the fuel forward to change the CG. You can see that the forward bug is now actually starting to move forward, and soon we'll be in a position to move the centre of gravity.
Well, we're actually still maintaining 53,000 feet now. We did get a bit higher, but as the temperature got warmer, we slipped back down again. And 53,000 feet is where we finished at levelling off before we start our deceleration. We're holding this high, partially closing the throttles, as Roger said, and we're waiting now for the speed to come back to 350 knots, as we did yesterday, and that will be the speed at which we set off, actually descending as well as slowing down as well. Slowing down in that we maintain the indicated airspeed, but the Mach number continues to reduce, and we're aiming, of course, to get down below Mach 1 at a calculated point. The boom carbon, when we're flying at high speed, is about 15 miles long and about 20 miles wide. That's the area affected by the shockwave on the ground. And that's thrown ahead of us as well. And so to make sure that we don't drop the boom on land, we need to be subsonic some 35 miles before we cross a coastline. And then to be on the safe side, we add another 20 miles. And we're actually looking now for a decent point at which we should be subsonic, which is 55 miles before Combe Martin in North Devon. In fact, a place just inland of Combe Martin, just south of Ilfracombe in North Devon. If we make that at 55 miles, then we won't be dropping a boom on the land. We're reaching Mach number 1.5, and Roger's now going to take the second stage of throttling. Thank you, Roger. So we calculate those figures for our descent. We don't have computers that do that. We have tables and charts and check our weather and temperature and wind and make our decision. It's an estimated position for our descent.
We're now also going to start the CG moving forward. So I select the trim transfer auto master and it switches on the 2 electric pumps in tank 11, and in this case it has opened up 2 inlet valves to tank 9. That's because I've got 8,000 set within the load limit controller. I now no longer need that, so that I can wind that
Zulu's given
down to 0, and in fact when we get it to 0, those 2 inlet valves will close as they are now, and the 2 for tanks 5 and 7 will open, and we're now transferring fuel from the back of the fuselage out into the wings.
We've started our descent now, and we're coming down to settle at 350 knots, coming down through 50,000 feet.
We're now also looking at our ramps as we're coming to 1.3, and we're looking for them to actually come fully up. We indicated earlier that we actually don't need the ramps below 1.3 because the intake geometry provides the slowing down of the air of its own accord. 3 of them have come up. We're still waiting 1 more to come. Down to 1.29. The reason they come up at different times is because they're all sensed individually, and there is just slight changes between the sensing. They are now all fully up. The ramps are up.
We're clear to descend at the moment down to 37,000 feet, although for a few seconds we're going to level at 41,000 feet while we actually complete the transition through the speed of sound slowing down. This means that it's enabled us to stay supersonic as long as we possibly could, and it's a more efficient way of operating. Once we're subsonic again, then we'll advance the throttles back to an intermediate power setting in order to warm up the engines, and Roger will describe that when we do it in a short while.
autopilot.
Autopilot is now acquiring 41,000 feet. That warning horn is to remind us there's 1,000 feet to go, 1,000 to go.
Check 1,000 to go.
I'm checking the distance to go to Combe Martin, get an accurate fix on our descent, on our subsonic point. Temperature's actually increased quite a lot during the descent, so probably means that we're going to be subsonic just a little bit earlier than we need have been. But that's on the safe side, far better than being subsonic later. Now set 37,000 feet in the autopilot heights control, and that'll continue. The autopilot will continue to fly us down to 37,000 feet as we go through 40,700.
Right, Mach 1.
Mach 1 check.
Going on.
Just coming through Mach 1.
56.5.
Make 86%, please.
86% is coming up. We select 86% at this stage to even out the temperatures within the turbines and to make sure that we do not get sudden temperature changes. The turbines are very sensitive to temperature change, and we take an intermediate power setting for 1 minute so that we can do it gradually. We also need to go back into our checklist.
6.4.
An altimeter check, please, Roger.
Yep.
Through 40, 1013 each side. I've got 56.2. It is moving forward.
Checks.
I'm also going to set the pressurization up now. It's currently set at 5,500 feet, and I move it very slowly because it'll surge slightly as we start to go. In fact, the pressurization on this aircraft is so smooth that people sometimes don't notice that it's actually changing. So we surge it slightly to make sure that everybody is aware that the pressurization is going down, and they will need to clear their ears. I've set it down to ground level, and it will now go down at about 350 feet per minute.
Yeah,
the cabin altitude will be coming down through 5,000 feet. We need to put the pressure static heaters on because we're now down into the cold regime of flight for Concorde, and we need external heating. Checked 1 to go. Transparency de-ice demist.
They're all on.
That's our windscreens and transparencies in front of the pilot so that we can ensure that we get good forward visibility and no misting or icing. At this stage, we also change our throttle amplifiers to make sure that the one that has been staying dormant in a standby state is now fully operational. Changed 1 over, 2, 3, and 4. They're all okay. The descent checklist is complete. The fuel is still moving.
Thank you, Roger.
One of the other things that we talked about supersonically was the extension of the aircraft by 8 to 10 inches.
Now hold.
We're now subsonic, and if you remember, I was able to get my complete hand in here. Now I can't do anything at all. The gap has closed right up, so that there is hardly any gap at all.
Now, of course, with subsonic, we can take whatever radar or air traffic control directions they give us in terms of turns and headings and descents, and behave just like a normal aircraft, although, albeit at this moment in time, just a little bit quicker.
I can't do that either, because it'll interfere with it.
We'll maintain 37,000 feet for a while now, until air traffic control either tell us to descend, or we calculate that it's about the time we should start our next stage of our descent down towards Heathrow Airport. Latest weather we just had for there says that it's gusting from the southwest, just exactly as it was forecast when we were at Kennedy Airport, with some high cloud around. Looking out from where we are now, we can see some cumulus and some quite big cumulus clouds around, so there's obviously some weather to avoid if it gets a little bit lower down. Temperature's 20 degrees in fact at the moment, and we are landing on 27 left. That's the southerly of the two west-facing runways. Actually, they're also reporting that other aircraft are reporting some wind shear. That's a sudden change in wind direction, which affects the speed of the aircraft during the approach at low levels on the approach. It's a change of 10 knots, which is not huge, and Concorde is actually very good. It has a superb autothrottle system and handles wind shear superbly, and with that figure, that's a warning now for me handling the aircraft to be prepared for that. And for that eventuality, I'll add a little bit more speed onto the approach speed, just in case that speed drops off in the final stages of the approach. Okay, Roger, to that effect, we'll add the full 10 knots on and make it...
Okay.
Yeah, good idea.
153163.
All right.
We've now levelled out at 37,000 feet, and in fact, we have brought the fuel CG forward to our subsonic CG position, which is approximately 55%. All the time we're flying level above about 31,000 feet, we will hold it in this position. When we start to go down and to reduce our Mach number, then we will have to move the fuel forward again to bring it to our landing CG position, which today we're aiming for about 53.1. You can see from these gauges that the forward and aft limit bugs for the CG have now moved from well towards the lower end of the gauge right to the middle. On landing, they'll actually be up here, and we will continue to move the CG to keep it between the two limit bugs. The amount of fuel that we have left now is only 2,600 kilos in tank 11, but all the rest has now been transferred into the main collector tanks in the wings. And in fact, we will end up with all the fuel on the aircraft in these main collector tanks, because they're the ones that feed direct to the engines. During our supersonic cruise, one of the other functions that the engineer undertakes is to take a set of engine readings that I did as we came across, and I put them down on this sheet, which is then given to our engineers on the ground, so that we can get an instantaneous indication of how things are going. However, some of these figures I put into a computer that all the flight engineers on this aircraft carry, and it evaluates the actual readings and gives us a trend indication. This trend indication that we get from our computer, we then put down into this area here, and then actually transfer it onto a graph system, which is kept with the aircraft. And you can see the one I did on the way out to New York, and the one that I have just done here. There are changes, as you can see, but these are quite normal, because the outside air temperature changes, the engines change, all sorts of things change, and you will find small fluctuations in these systems. This particular system has been extremely useful for Concorde and was developed for us right at the beginning of our operation, so that we could continually monitor the engine conditions as we went along.
So we've been flying for a while at 37,000 feet, and air traffic control has now cleared us down first of all to 19,000 feet and then 14,000 feet. So we've pitched the aircraft forward, put the autopilot into a Mach hold mode, which is to get it to maintain the Mach number that we were cruising at the time, and I've closed the throttles, therefore there's no alternative but for the aircraft to go down, and it descends. At the moment we're descending about 5,000 feet a minute. As the speed comes through 350 knots again, as we slowed a little bit below 350 indicated when we were cruising at that Mach number, then I pitched the aircraft up slowly and asked the autopilot to maintain a speed of 350 knots or thereabouts.
Through 30?
Yeah.
Mach number reduced.
290 down to 140
Understood.
now, and 55.2.
55.1 checks.
Fuel is moving forward.
So now as we fly down the flight envelope at a fixed airspeed, the Mach number is now going to reduce. So we're descending, reducing Mach number, fixed indicated airspeed, and air traffic control wants us at 14,000 feet, 40 before the radio beacon at Ockham, which is just to the south of London, not far from Epsom. Again, modern aircraft with electronic systems would set this requirement in, and the autopilot would do the calculations. This aircraft being slightly older technology means that we tend to have to do the calculations in our head, and therefore there's quite a lot of cross-checking going on to make sure we all agree with the figures we've got. We've got 12,000 feet to go, which on a normal day would be about 24 miles to get down to 14,000 feet. It's quite a healthy tailwind, so I've added another 5 on top of that, which is 29 miles, add the 40 miles, which is 69 miles. In actual fact, we had 68 miles, so it looks like we're nicely set up in the slot to get down to the 40 miles. All the time, though, I've got to keep my eye on the temperature, because suddenly a decrease in temperature will affect the performance and make our descent slower, and also, of course, an increasing tailwind will push us along the track a lot quicker and mean that we'll get to that point quicker and therefore probably higher. So all the time we're monitoring temperature, wind, our airspeed, our descent rate. We're now being cleared down to 11,000 feet. Just going to go through 14,000 feet about 2 miles before they wanted us, which is just on the right side of things. And under radar headings now round to the south of Heathrow Airport. They'll take us round to the south and then turn us through a heading of north over the centre of London and in a westerly direction down towards Heathrow Airport. Speed at the moment is still 350 knots. And gradually, as we get a bit closer, we'll start bringing the speed back. As we come down through a speed of 270 knots, then we'll select the visor down, the nose down to 5 degrees, ready for our speed of 250 knots. And then finally the nose all the way down for our approach to landing.
Okay, for the approach checklist, Dave.
The approach check, please, Roger. Yes, thank you.
90 check.
9
9,000
checks.
feet.
Approach checklist, landing briefing update.
Right, no addition at the moment, just to confirm, remind us that the go-round is ahead to 3,000 feet.
Understood. Taxi turn lights.
Okay, they're back on.
Rad INS switches.
Rad.
Radio.
Engine rating going to take off. We now take the engine recirc valves off because we have high fuel flow at low levels through our system, and therefore we don't need the recirculation area that's going on. We, however, do set the engine up using our primary nozzle for what we call an approach setting, which is a combination of noise, minimum noise, and also reasonable power for our approach. Approach coming on now. You saw that we went from high to the mid rating. We check all the fuel pumps are on in our collector tanks, that the cross-feed valves are shut, and we then look at the fuel panel to make sure that we've got everything in the right position. These lights that are flashing on the fuel panel are indicating that we're scavenging the last remaining bits of fuel out of those tanks to put them into our collector tanks so that they are usable to us. When they stop flashing, then we can actually take the pumps off.
Cabin is now secure for landing.
Thank you, Russell. We've now got all our fuel into the collector tanks, with the exception of one small part which is up in tank 9, which is achieving our CG of 53.2, which is what we need for the landing at this stage. We then check our electrical panel, and in fact if we were going to do an automatic landing, we would set the electrical panel up so that it was actually independent from one side to the other on the AC side, and that the DC sides were split as well. We're not automatic landing today, so I just check to make sure that the switches are in the correct position.
Okay, riser going down. Hesitant. Nose going to 5.
Fuel weight CG checks, no update on the bug 153, the basic.
And 53.5, thank you.
Seats and harness.
Lock secure and the power off. Air traffic control just told us, despite what they said a few minutes ago, that there may be a short delay, so they're sending us to the radio beacon at Ockham. It's a VHF radio beacon, very accurate reading of the VHF beacons, and we go to a holding pattern over there. The holding pattern literally is a racetrack shape, and it's inbound on a magnetic track of 332 degrees, with right turns overhead the beacon. We're heading for the beacon at the moment. We're level of 9,000 feet and doing 250 knots. They said 5 to 10 minutes delay, which probably means we'll just go around the racetrack once, and then they'll take us off on radar headings to take us into the approach. And the racetrack pattern here, there's the Ockham beacon, there's Heathrow Airport, and the racetrack pattern goes around in that direction, and we're coming down in this direction now towards it. So we're just entering the hold at Ockham. The beacon's just, the needles on the beacon are just about to go round to indicate we're going overhead. In fact, there they go. Start my stopwatch. And we go out on a computed or calculated track for a while, just for 1 minute. We've got a wind that's pushing us along a little bit, but not too much. And then we'll make a right turn all the way back to the beacon, which is now, of course, behind us. And when we turn right, we'll be round on our right-hand side. I'm turning the aircraft by using the heading selector. I've got the autopilot selected in track heading mode, which means it'll steer whatever heading I select on my index. The autothrottles are maintaining our speed, and the autopilot's holding our height. Now through 50 seconds. I'll not go much further out there, but make a partial right turn to the downwind leg, go to 9 miles. And the bound leg of the racetrack pattern. We're allowed at Ockham to go to a maximum distance of 8 miles from the beacon. And as well as having a needle which tells us where the beacon is, this is one of the VHF beacons that also tells us the distance from it as well. So we can work this out quite accurately and fly these holes quite precisely.
Traffic. Okay, we'll look out there.
Yep. The electronic words traffic came from our TCAS system, which indicates almost certainly a light aircraft underneath us with no high readout. And it's not saying there's a danger, but it's telling us that there is some traffic in the area and we need to keep our eyes open for it.
4 checks.
1003, 4,000 feet checks.
Altimeters, radio altimeters. 1003 checks both sides. The approach check complete.
Thank you.
Heading 100 degrees.
Still up to about 22 miles, 27 left, speed 210.
Back to 210.
The traffic controller now told us to come back to a speed of 210 knots. We're descending to 4,000 feet. Just coming through the worst of the cloud there, there's quite a big break in the cloud over the centre of London. It looks quite bright and relatively cleared. In fact, from my seat now, I've got a lovely view of the centre of London. We're heading at the moment almost directly towards Croydon.
Left heading 300, establish 27 left.
Left heading 300 degrees, call it establish 27 left. Degrees, call it establish 27 left.
London, give that 779. Good afternoon, turning right from heading 090, descending 5,000 feet.
Chicago 779, road to 22 miles, 27 left.
Turning left now to head through north round to a heading of 300 degrees. Just skimming through the tops of a few clouds here, nothing very much, and coming into view on the nose of the aircraft, the City of London, in fact the Isle of Dogs area of the Thames very clearly coming into view ahead of us.
345, not less than 160 knots to 4 miles, tower 1187 tonight.
187, 345.
As we come out of the cloud, you can actually see Canary Wharf quite clearly out there, and the River Thames standing out very clearly. City of London on the nose now. We're coming all the way round, so we're heading northwest to establish
Captured to
westbound inbound to Heathrow. Flags are clear. Warlock primed is set. Glide's active.
Yeah, I'll join you on the island.
Glide primed, and you can join me on the ILS. Thank you.
Chicago 779, descend altitude 4,000 feet.
4,000 feet, give that 779.
Shuttle 3 meters, service. 3 vector descend with the ILS, not less than 160 knots to 4 miles, tower 1187 tonight. Right, descend with the ILS,
No glides are active.
4 and 187 grenade.
Warlock capture.
Warlock capture.
360.
Left heading 360, give that 779.
332 is an established road line, 279.
You
need to use the autopilot.
Depth 2 selector, autopilot going out.
121.
Established glide and lock more.
Give it 345, clear to line 27 left, 230 at 15.
Good land, 27 left, 0345.
Some 3 meters, 4 nautical.
Thank you, C Victor. Number 2, the wind 220 at 20.
2 meters.
Yeah, I'll put the go around altitude in 3,000 feet. Line capture on the flight director.
3 check.
Checks. Just coming out to 10 miles, take the gear down, the landing check.
Okay,
Landing gear. Oh, that's hydraulic.
Hydraulics.
Oh, that's... It's cleared. It was just an intermittent low pressure light on the yellow.
Thank you.
4 green.
Checks 4 greens.
4 greens.
Nose.
Collected down.
Down
And
green.
green.
Brakes.
Check normal.
We now check our anti-skid to make sure we have 8R lights down on the front of the panel here, so that our brakes are deactivated until the nose and the main landing wheels are rotating at the same rate.
Okay, the gear is locked down. That's okay.
The landing checklist is complete.
Thank you.
Radio altimeters are both active.
Right.
Leave it at 2 miles. Give it 2, thank you. Click the line on 2.
10,000 feet radio.
Right, 5 greens, go around altitude, set.
Check. .800 feet.
Flight director's dropped out.
Yeah, that's my one, I'll try it again.
Thank you.
500 feet.
Okay, stable.
2-1 check, 200 at 20 knots.
400 feet.
London, sorry, you said level 79, good afternoon, establish descent.
100 above.
779, good afternoon, continue approach.
300 feet.
210 at 20 knots.
London, you said level 79.
This side.
200 feet.
Director off, please.
100 feet. 50, 40, 30, 20, 15.
Tower, good evening, Kilo 456, it's block 118.
Kilo 456, hello, block 86, cross runway 27 left now.
Block 86.
Another stick forward, please.
Stick forward.
Kilo 456.
100 knots. 75 knots. 50, 40.
Yep. Nose to 5, please.
Okay, nose 5.
Checks and 2 and 3 off, please, Roger.
Okay. Off the landing check. Master warning.
Okay. And here it is.
Nose is up to 5. Flight control inverters.
Okay, good.
At this stage, we start moving fuel forward into tank 9 by taking it from tanks 2 and 3 and putting it into tank 9 so that we can make the aircraft nose heavy. This means that they can unload the aircraft in whatever way they like and it will not cause a centre of gravity problem. So we are waiting for tank 9 to get the necessary fuel in it. Equally, our engines, as we said, are very powerful, and even with a very heavy aircraft, 4 engines is very powerful for a taxi. With a light aircraft, as we are now, we close down 2 of them, number 2 and number 3, to make it easier for taxiing. 2 and 3 going, Dave.
Thank you.
The rest of the checklist is switching off the things that we don't need any longer and setting the aircraft up for being on the ground.
Okay. I have control.
Our brake temperatures are indicating now with red lights for each of the wheels. This is completely normal. They come on at 220 degrees, and when we land on a runway the length of the one at Heathrow, we have probably somewhere between 300 and 400 degrees on the temperatures. We've actually got 340 at the moment, which is the highest, but if I select all the others,
You have control.
you can see that a number of them are actually well below that. We now go back to tank 9 to see how we're getting on with the fuel, and I'm going to hurry that up again by putting it all 4 collector tanks, pumping fuel into tank 9. 3,600 thus far. We're looking for 4,000 kilos. And we now have our 4,000 kilos. We shut the collector tank pumps and shut the inlet valves to tank 9. And I now have to go onto the PA to tell the cabin crew to place the doors to manual. Cabin crew, this is the flight engineer. To place the doors to manual. Doors to manual now. That disarms our doors from the automatic chutes that would otherwise deploy if you actually open the doors. After landing checklist complete, I've called for the doors.
Set to park, chocks at 3.5, nose and visor up, please.
Brakes parked. Lights transparencies.
They're all off now.
Visor nose coming up.
Up and up.
Shutting down number 1 engine. And we check on the engine instruments to make sure the engine runs down. We keep number 4 running at the moment to supply us with electrical power until our ground power unit is plugged in underneath the aircraft. I'm waiting now for the ground engineers to come onto the intercom to tell us that it is plugged in and available. Go ahead, sir.
They've just plugged the power in and we've got trucks in at the nose.
Thank you. Our ground power has just been plugged in and I have an indication on the electrical panel that is satisfactory. So I've now put it onto the aircraft and I now close down the last remaining engine. Finished with the INS?
Yes, report number 2's 12 miles, that's getting a little bit towards its limit.
Number 2, 12
miles unmixed.
Okay. Checklist and data computers. Flight control inverters you've done. Emergency lights. Oxygen. Ground power. Just the master circuit breakers to come, Dave.
So here we are back at Heathrow's Terminal 4, a little over 32 hours since we left yesterday on the BA 001. I hope you've enjoyed the programme and been able to get an insight into how we fly Concorde and how it works. As I said right at the very beginning, we've been in a very much a live aircraft environment, both in the maintenance area and of course here on the flights. With our short flight times, we've been compressing a lot of activity in just a short period of time, but I hope nevertheless you've been able to see how we operate and how we fly the aircraft. I'd like to thank a couple of people who've been very helpful in making this programme. First of all, of course, our co-pilot, Les Brodie, who's been looking after us on both the flights, and the cabin crew led by Russell Bairstow, who, as well as looking after our high-profile Concorde passengers, have been managing with the camera team in the cabin and, of course, all their equipment. And, of course, Roger Bricknell, who's taken you around the outside of the aircraft and shown you how many of the systems operate in the aircraft, and we're very grateful to Roger for that. British Airways operates scheduled services with the Concorde, and, of course, the 7 aircraft operate a whole range of charters all over the world. Many of those charters get to cities in the UK, and I hope you get a chance to see Concorde, and we look forward to seeing you on board sometime in the future.